Hi,
Be
James.
impressive. Thank you.
Hi, Ivan.
Hello.
How are you doing, guys?
Well,
Fine.
it's the middle of a pandemic and a presidential election, so I'm hanging in there.
So, and also
We are
it's
the
very
best we can
early
be in
morning.
2020.
Yeah, so James, it's also very early morning for you. So it's so glad to see you, and I hope you're doing well
I'm
with
ready
coffee.
for it.
That's great. That's great. Ivan, do you have any questions before we start?
No, I'm all
No,
pumped
I'm
up
ready.
for the talk. Yeah, let's go for it. It should be great.
Yeah, so let's go then.
All right, let's do this thing. So welcome to my music room in Seattle, Washington, halfway across the world. I'm wanting to take you all on a journey during this next hour or so and talk to you all about the journey that software testers before you took to get to the point where we are today, and then push you all a little bit into the future where I believe you're needed. So 30 years ago, 30 short years ago, we lived in a world of paper and ink. That's how business was conducted. That's how commerce occurred. Any work you wanted to do, you put it on paper and you used ink to make marks, and people moved that paper from one place to another, and that's how work got done. It was all manual. If you needed anything done, humans were required to do it. This was a very long period, and humans got good at paper and ink. Warehouses full of these things called file cabinets, and we would take pictures of it and put it on microfilm. Libraries and card catalogs to organize all of this paper. And then in the 80s and 90s, there began a transition, this new technology out there called software. And frankly, not everybody believed in software. Of course, all those companies are gone, but there was a resistance to this business model. Small businesses didn't understand it. They look at mainframes, right? It's a big business. That's a big government kind of thing. And PCs came out, and now all of a sudden there were applications for small businesses and homes, and then the web, and then of course mobile, and that takes us to where we are today. But in the 1990s was a crucial period for this technology called software. That's when everybody was beginning to realize its potential. Not everybody understood it, but they were beginning to realize its potential. And the potential of software was that instead of all of those humans to do all of those things with paper, you could digitize that information, and you could take the repetitive parts and automate the crap out of them. And all of a sudden, there were fewer people who were required to do business. All of a sudden, the shift in the balance of power went from humans who could do paper really well to humans who could do software really well. And it was a bumpy ride. The software developers in the 1990s didn't know what they were doing. This was a new technology. They didn't fully understand it. And of course, it went off the rails. Software bugs were prevalent and costly, right? We were shipping disks of software back then. We'd take the software, we'd write it, we'd put it on disks, and then we'd ship those disks, and the people would install them on their machines. If there were bugs in that software, we had to recall all those disks and make new ones. It was expensive, and no one quite knew what to do about it. And then the role of software testing was invented. That's right, invented. It wasn't there before. There weren't cadres of people who were simply responsible for testing. Because in the mainframe days, it didn't really matter. In the mainframe days, all we did was just train our users better. If the users accidentally entered an input that caused the software to crash, that was their fault. They should have known better. Train your users better. And IBM and Digital Equipment Corporation and all these companies with all these resources, these field resources, they'd go out and train users how to use their software. PCs changed all that. Now all of a sudden you're just shipping software to thousands, tens of thousands, hundreds of thousands, millions of people. You can't train them all. There was this need to make better software. And this class of people called software testers answered that call. And we developed the technology, I'll talk about those technologies in a bit, that allowed software development to be more controllable, to be more predictable, to be higher quality. And then the sort of penultimate bug came along with the Y2K bug. Many of you all were probably not even born, or you were very small at the time clocks changed from 1999 to 2000. But that really put software testers on the map. The Millennium Bug, they call it a bug, even though it wasn't. It was a design flaw. It was a purposeful design to store dates as 2 digits. So the year 2000 was interpreted by computers as 1900. I'm not going to talk too much about the Millennium Bug, but this is how front and center, this is how important, this is how 6 o'clock newsworthy software testing all of a sudden became in the late 1900s. And so by then this shift was complete. People no longer did stuff on paper and ink. We were just digitizing the data, and then the data was born in digital form. Software testing by that time had become something that mattered. But there were some chinks in the armor, and there were classes of bugs that went beyond just crashes, classes of bugs that went beyond the way the technology would be used. And we created new words for these classes of bugs. 2 bugs are on the screen right now. The one on the left is a bug called the brain. It was generally considered the first virus for MS-DOS. It overwrote the boot sector and slowed a computer down to a crawl. It was developed by 2 Pakistani developers who were angry that their software was being pirated and wanted to do damage to the people's computers. And this thing was a purposefully built program to keep people from working. This was in 1986 that this was released. So in 1986, the software world understood that viruses and worms and malware and all of these vulnerabilities, all of these terms that we now throw around were a possibility. What did they do about it? This virus, the brain, went to dozens and dozens of countries, thousands and thousands and thousands of computers. It was a proof that someone could maliciously manipulate software. The one on your right, AOL, right? AOL. That was the first networking bug. It was that was exploited. It was the first exploit for phishing, really. It would tempt you into going to a chat room, and then it would take over your computer. Phishing, aha, there's another new terminology. this is a good way to plan your career. When people are making up words about shit, it's gotten enough attention, and it's important enough that people have called it something. This is a hint. This is important. You might want to pay attention to this. The world's first phishing attack, and I think it was 1994, if my memory is correct. And then throughout the 90s, we had, in addition to the Y2K bug, we had all of these viruses, all of these worms, all of this malware, and and just name it. There's viruses, worms, malware, ransomware, cyberbullying, revenge porn, all this stuff, right? The software itself was designed in a way not for quality. It was designed not for security. It was designed so that people could generate wealth. We built software-based systems for productivity and wealth generation. And it was the software testers of the world in the 1990s that said, hold on a fucking minute. There are some serious problems with this technology. Can we just stop? And of course, they couldn't stop. But what happened was a software testing world, and we're now fully in this software testing world, a thriving software testing research world in the 90s and early 2000s. That's where the tools came from. That's where the technology came from. That's where people like me started writing books and building tools. And my first startup was a software testing company, trying to warn the world that this technology called software is going to be important. It's going to change the planet, and it's got some serious problems. And that's how we had conferences, big conferences. We would argue at these conferences. I still have opponents from back then to this day, because we understood that this is important. And now we stand on the precipice of another shift that's, I think, as big as the shift from paper and ink to software. And now we're going from software to AI. And many of the same things are happening in this AI world that happened 30 years ago when we were discussing moving from paper and ink to software. There were some people who didn't think it was anything interesting as software. Yeah. I mean, IBM kept making typewriters. And look what happened to them. Digital Equipment Corporation is no longer around. All of these companies that Sun Microsystems, Unisys, Sperry, Rand, all of these companies that were betting on old technologies and didn't see it coming. AI is a different beast. It's not software. It solves problems. Look, software took a bunch of the humans that were involved in this paper and ink economy and made them no longer necessary. AI makes even more humans unnecessary, because AI can do something that software cannot. And this is what we as software testers need to get our mind around. AI doesn't just replace the repetitive tasks like software does. AI is capable of human reasoning. I say that unqualified. It's not, it simulates human reasoning to a point that AI and human reasoning is indistinguishable. In some cases, human reasoning is still superior. In many other cases, AI is already better or will become better over time. It's a different beast. Software testing techniques don't apply to building an artificial intelligence, just like the techniques we use to test paper and ink systems. It didn't work on software. And so we're also at the point where AI is beginning to exhibit the same problems as software. The same sorts of disasters are occurring or will occur, and we'll talk about those in a bit. But fundamentally, these two technologies are different, and we must get to the bottom of this. As software testers, we are being called right now to answer the same sorts of questions that we answered back in the 1990s about software during the transition from paper to software. Who's asking those questions now? How do we keep AI on the rails? We worked it out with software. We built the tools. We understood the processes. We helped software developers do a better job. What are we doing in AI? AI is far more complicated. Do you understand how to build an AI? Do you understand how to keep it on the rails? Look, software was relatively straightforward. Once we really dug into it, software basically consists of four things. Inputs that are mapped to outputs using data structures and control structures, computation. That's it. That's what software is made of. It's written line by line, and those are the four things it does, and that's all that it does. It took us a few years to figure that out. It took us a few years to simplify it, to boil software down to that essence. And then, of course, that's when we went crazy on the technology. I wrote 5 books all about how do you do this? How does a software tester think about the input domain? How does a software tester create variation in the input domain? How does a software tester think through which inputs might cause a software to crash? How does a software tester think through which inputs are most likely to be applied in certain environments? How does a software tester force an output to occur? How does a software tester force a specific computation to occur? That's what those 5 books are about. I wrote those, I think the newest one is 2011, over a decade, about a decade ago. The first one is 1999, How to Break Software, still in print, because it is a fundamental analysis of how software works and therefore how it will break. Who's done that analysis for AI? This was opportunity. I got into software testing at an early enough phase where I could make a contribution so lasting that How to Break Software is still in print 20 years later. If it was a car, it would be called a classic, and it would be selling at 10 times what it was 20 years ago. But it ain't a car, but it's still around. No one is making those fundamental insights for artificial intelligence. So let's start that process now. Let's do the same thing that we've just done for software, for AI. What is AI all about? I'm going to give 2 examples of this, but I'm going to go through it first. I'm going to summarize it first, and then we're going to talk about 2 examples of how AI works. Same way we did with software. Here's how software works. It accepts inputs from its environment. It stores those inputs in internal data structures. It computes based on those inputs and other stored data, and then it produces an output. What could go wrong? And that's the problem that we've been solving for the last 30 years. What does AI do? AI fundamentally, I guess, is software. I mean, it's a binary running on a microprocessor. Fundamentally, it is. But that's the first difference that we have to, software runs on computers. Software runs on mobile phones. Software runs on anything with a microprocessor. So does AI, but the form factors for AI tend to be a lot different. If I say, picture an AI in your head, a lot of people, because I ask them, a lot of people picture, some kind of humanoid type robot. I've even got a rendering of one there on the right of your screen. Maybe, but I think a much more contemporary view of what an AI looks like is probably something like Alexa or Google Home or Siri. It's different. And the first thing that really stands out with an AI is that there's no user interface. There's no GUI to test. You speak to an AI. In fact, the company I work for now, Define Crowd, which is mentioned on the slide, that's what we do. We build data sets for speech, or text to speech, or understanding human conversation. And so this is data that we do this from. And I'm going, like I said, I'm going to give two specific examples, and we'll take apart the testing needs of this. But AI starts with data. And here, if I had to summarize it, I would say that where software is programmed, software is intentionally programmed, one line at a time. AI is not. It's trained. Right? You don't write the code for a car to navigate a roundabout. Go on, write that code. You can't. Right? There's no if then else statement. There's no case statement. There's no switch statement where you could come up with all of the different possibilities. Because driving a car with software is impossible. But you can train a car to drive. You can show it thousands, hundreds of thousands, millions of examples of here's the data for cars navigating a roundabout. Figure it out. That's what AI does. We train AI similarly to the way we train humans. That's what humans do. If you've ever taught someone to drive a car, you go and you put them in the car and you take them around the city, take them around the countryside, drive around the town, and they learn the rules as they go. That's what AI does. It takes raw data, and the first step of this is labeling that data, helping the machine understand it. Right, here's 10,000 pictures of cats, and you label them. These pictures have cats in them. And here's a whole bunch of pictures that don't have cats in them, so they have the label not cat. And over time, the AI figures it out. Whereas code is the primary artifact of software, right? That's the big thing. If you can code, if you can code, you make more money than if you can't code. In the 1990s, if you could code, you had a skill that few other people had. And of course, more and more people can code, but if you're good at coding, in the software economy, you made bank. AI code is not the primary artifact. Yes, when I build an AI, I have to write code. But more than that, I am manipulating data. Data is the primary artifact of AI, and that changes everything. All the techniques that we use that were code-centric, they're not going to work with AI. AI requires us to think about data. Let me make a prediction. Whereas programmers, developers, in the modern times are the most central to a team developing software, data scientists are going to take over as the most important part of an AI project, not coding. Because you have to recognize good data from bad data. You have to be able to label it correctly. Those labels help the algorithms to understand what's going on, because the algorithms are next. I think instead of at universities studying the nuances of programming languages, we're going to be studying the nuances of algorithms. And some of these algorithms have existed for hundreds of years. Right? The entire group of algorithms that fall under Bayesian statistics are 200 years old. And these are some of the primary algorithms we use to train AI. Simple things, curve fitting, least squares, regression. All of these classes of algorithms have already proven really good at solving certain types of problems. So instead of studying the nuances of data structures, instead of studying how control structures work, instead of studying whether to use an if statement or a switch statement or a lookup table, instead of a while loop versus a for loop, none of those skills are going to matter. The skills that are going to matter are your understanding of probability statistics. Look, if there is a root theory of AI, it's statistics. It's stochastic processes. You could dig down to the roots of the AI tree, you'd find people like Markov, you'd find people like Bayes at the root of those trees. And so this is the next step. You take your data, you label it, you organize it as good as a human can, and then you stick the algorithms on it. And there's multiple classes of algorithms. This isn't a talk on AI, this is a talk on testing. But there are multiple classes of algorithms. There are statistical algorithms. There are stochastic algorithms, statistical algorithms with structure. Your countryman Markov is one of the founders of stochastic process theory. And then there are layered models, deep learning models. We'll talk about those in a bit, but those are the three classes of models. You're going to have to get really good at this. You're going to have to be able to look at data. A good data scientist can look at data and say, that's probably the algorithm we should start with. But that's the process. Get the data and just start running the algorithms through it and hope that those algorithms start finding patterns. And this is where the skill at AI really is what differentiates a good data scientist from a mediocre data scientist. Just like there are certain types of problems, right? Like kernel mode programming that would point out the difference between a really good programmer and a really mediocre programmer. Is picking the right algorithms, understanding those patterns, and then iterating, combining algorithms to generate patterns. Pictures of cats. You run enough pictures through enough algorithms, and all of a sudden, one of those algorithms is going to emerge as a thing that, hey, that's pretty good at picking a cat out of a picture. And then finally, that feedback loop, the ability to see. This is one of another fundamental difference between AI and software is that software never changes. We build software, we release it to the field, and it just does the same thing over and over and over and over again. It does it at speed, it does it with great skill, it does it with great precision. But once it gets out in the wild, it doesn't really change unless humans update it. AI changes. AI and automated an artificially intelligent car will go through a roundabout and it might discover something new. It might discover, a car driving the wrong way on the roundabout. And once it figures out what to do, right, that's new data. That's the thing about AI. It keeps learning even after it's released. We've never had to deal with this as software testers. We've never had to deal with something that changes after release. We've always been able to assume, here's the software. This is the software that was developed. This is the software that we tested. We fixed some bugs, it changed a little bit, and then we released it. It's still the same software. It does the same thing. It takes the same inputs. It produces the same outputs. The data structures didn't change. Software didn't wake up one day and say, you know what? Fuck that shit. I'm tired of processing those inputs. I'm going to do something else. That's not the way software works. But AI does work that way. AI gets better. You got a bunch of self-driving cars out there driving around, sharing all their data. That's the feedback. That starts the process all over again. How do we handle that as software testers? Handling uncertainty in inputs. We're good at that. Handling the uncertainty of an environment, that user is different than that user. And if you put it in a lab environment versus an office environment, we're good at that. Those things translate to AI. All of this theory that we have developed in the 1990s and early 2000s, it applies to AI. It's just not that easy. It doesn't apply that directly. Think about this. This is the biggest opportunity in software testing that exists, except it's not. We should probably call it something else. I don't know what we call it. But it ain't software testing. And I don't know where the technology is. It ain't there. We have a QA team, a defined crowd that are very good at what they do. We haven't codified it yet. Not like it was codified with software. Every day we come up with new problems, new ways of thinking. And this is why I wanted to give this talk, is because that's what happened in the 1990s. We would discover something new. We were going to conferences in the 90s. There were two of them. Quality Week, which is gone. I think they stopped in like 1998 or something, or 2000. I think the dot-com bust killed them. And Star, which is still around. It's changed ownership, but it's still around. And it wasn't about just experts getting up and giving talks and trying to teach the muggles, right? That's what they've devolved into now. It was about discovery. It was about, here's a really freaking hard problem. There were workshops on that. Hard problems workshops at Quality Week. Here's something we don't know how to do. Let's all sit around a room, share our experiences and talk about it, create something and write a white paper at the end of it. We need to do that for AI. Is it important? Yeah, it's important. So here's two examples I want to walk through, how we do this, because I think it's important to really understand at a fundamental level what is exactly going on with artificial intelligence that makes it different. So these two problems, one is self-driving cars and the other is counting people in a room. Both of them are very hard. Both of them impossible to do with software. The reason we didn't have self-driving cars before is because we didn't have AI at the level that we have AI now. Software cannot drive a car. Now, what software can do is it can collect data, and that's really the first step of artificial intelligence, is collecting that data. And so just like a human has sensors, right? I've got sensors here, sensor here, sensor here. And I collect data with that. Cars do too, right? They have near field sensors, they have microphones, they have cameras, they have LiDAR, they have radar. And they're able to interpret their environment. So that's step one. Gather all that data. And generally, that falls under what people call the Internet of Things, IoT. IoT and artificial intelligence really cannot be separated. IoT is all about collecting data. Artificial intelligence is all about learning from data. In many ways, IoT is one of the interfaces for AI. And then it just starts learning. It learns how to make a right turn. It learns how to make a left turn. It learns how to go straight. It learns how to recognize a stop sign. It learns how to recognize a traffic light. It learns the difference between red, because of patterns, because it's got all this data. Once it sees 1,000 stop signs, it recognizes a damn stop sign. That stop sign could be straight on, it can be cocked a little bit, it can be bent. And it recognizes it because it's seen it enough times. That's the difference. Software is programmed, AI is trained. AI learns like humans do. You've ever taught a child to read or their letters, show them the flashcards over and over and over. They guess it right, you're like, hey, good job. Guess it wrong? Nope, you did wrong. And we do the same thing with AI. We show it a bunch of examples, and when it gets it wrong, we change the way that data is labeled so it knows it got it wrong. Reinforcement learning. Now, another reason that cars can drive now, and they couldn't drive themselves 10 years ago or 20 years ago, is because of the cloud. the cloud changed the game with AI. In the cloud was invented, well, the cloud was invented earlier, right? We used to call them data centers. And, Google had a cloud, a proprietary cloud that did nothing but search. Amazon had a proprietary cloud that did nothing but e-commerce. Facebook had a proprietary cloud that did nothing but store social data. And all this is where AI, the modern AI, was born in these clouds. So, oh wow! I just got told that they've called the election for Joe Biden. So now you know where you were when you heard. So the cloud changed the game because all that data that AI is voracious for, that it needs to learn, right? 100 million pictures of cats takes a bit of storage. All that camera data from all those cars going through all those roundabouts takes a bit of storage. And the algorithm has to have access to it all. And before the cloud, it didn't. And so, Google's AI for search was one of the first sort of AIs that people used on a regular basis. Facebook's AI for social, Amazon's AI for shopping were really three, and they were behind the scenes. We thought it was software, but it wasn't. So the cloud mattered. Amazon was just the one that had the foresight to say, hey, you know what? Shopping isn't the only problem we could solve this way. And they invented the future. So we have to thank Amazon for doing that, because without the cloud, we wouldn't be doing AI, because we have to have a place to store all that data. So let's talk about this people counting in a room, because I think this is a really illustrative problem. I worked on this one last year at an IoT startup called Biscuit Labs. And we had sensors that we would put, right? And now people counting in a room, COVID turned it into a big deal because, there's restrictions about how many people can be together. And so we thought this through, right? The thought process is, I think it's a really good exercise for you to just take a problem and think about how you would train an AI to solve it. We thought, okay, how do we recognize a human in a room? Well, we could have a camera, and maybe we could track their face. Okay, that's an input. We could have a motion sensor. We just see if we can track movement. That's even cheaper. We could have a Wi-Fi access point, and then when we get a ping from their device trying to connect to Wi-Fi, we can count them. We could have a microphone in the room that would hear voices, and that way we'd know people were there. And so we built this device, and it was taking all these different signals in it. But all those signals were flawed a little bit. You couldn't write the code for, if you detect a voice, then that's one more person, right? Person plus plus. But how do you do that? How do you know that voice from another voice? How do you know you're not hearing the TV or a radio or someone talking outside the room and you're just able to pick it up with your microphone? It's good data, and it helps us solve part of the problem, but not all of it. Motion sensor. All right, we've just detected motion. Something in the room is moving. Is it a person? Is it two people walking side by side and the motion detector is only picking up one of them? Is it a large dog maybe that we picked up? That's data, but it's incomplete data. What about Wi-Fi access point? If I walk through a room and I've got my phone is pinging that Wi-Fi access point. Unless I've completely turned it off, see, now you can turn it off. Or I could have multiple. I could have a watch, I could have a phone, and I could have a laptop in my backpack, all of them pinging this. And now, instead of one person, I've just counted 3, even though there's only one person in the room. A flawed signal. This is a problem that cannot be solved with software. It's perfect for AI, Because here's the process. Here's all the motion sensor data. Here's all the Wi-Fi access point data. Here's all the microphone data. And at that point, there were 4 people in the room. At that point, there were 18 people in the room. At that point, there were, and then we went out and we tested this thing. We took it to arenas where there were thousands and thousands and thousands of people. We labeled that data with the ticket sales count. We took it into office rooms where there were people moving around. There was hardly ever more than 12 people and we labeled that data. So we took all the data, we labeled it with the answers that we wanted. There's 8 people in the room when the data looks like this. There's 1,600 people in the room when the data looks like this. There's 44 people in the room when the data looks like this. And here's where it begins to get a little spooky. We started running algorithms to find those patterns, and the algorithms started to get really good. Simple algorithms, statistical algorithms. We didn't even need a stochastic process for this. We didn't even need deep learning for this. Regression analysis was enough. And then we took it into a room that it had never seen before, asked it to count the people, and it got it right. And then it got it right again and again. It got a few wrong, and we tell it, no, there's 18 people, not 19 people. And it got better, and it got better, and it got better. To the point that not only was it better than us, I mean, you look at a room of 75 people. You ever play that game where you, I don't know, maybe we do this in America, where we're like, there's a jar of pennies or jelly beans or something, and the person who guesses the number the closest gets some door prize. It's hard. The machines are perfect at it. And here's a fundamental problem that I'm putting out to you guys. You solve this problem, the world will notice. If there was a Nobel Prize for software testing, and you solve this problem, you would win it. Auditability. How in the fuck did that algorithm figure out there were 19 people in that room? I don't know. I can't point. See, it's data, not code. AI is data, not code. Software is code. I can't point to the code and say, oh, that's how it got 19. We can do that with software. We can always reverse engineer software and figure out the bug, figure out the algorithm, figure out why it worked, why it didn't work. We don't know how to do that with AI. Now, I would argue that 25 years ago, we really didn't know how to do it with software either, but we developed the reverse engineering tools to do it. We need all of those tools, all of that auditability stuff for AI, because AI is already exhibiting the symptoms that software exhibited back in, what did I say, the brain virus was 1986? 2 examples. Let's take the one on the right first. The facial recognition system shows rampant racial bias, government study finds. Why? And this is a typical problem that software testers are going to be expected to find. Another Nobel Prize. So you start taking facial recognition systems and you put them on office buildings for access control, right? Look at your face. I recognize you. Open the door. Only white people get in. Because all of the training data, this AI was trained by a bunch of white people. It's pretty good at South Asian people faces too, because the data was limited. And so now we have to start thinking about things like, is there inherent bias in the data? What does it mean to have an unbiased data set? We don't know. We are at the very early stages of what's happening here with AI. And that's okay. It's not okay to not allow people of color in a building, right? Imagine if someone implemented fire doors that had this technology in it. And all of a sudden, there were certain people, because of their physical appearance, couldn't get out of a burning building. This is what software testers are. We are really good. We're all kind of breakers at heart. We're not builders. Software testing, the mindset of a software tester is to break things, to find the holes, to find the things that nobody else thought about. That's why we are perfect for this. We are perfect at imagining these nightmare scenarios. We are perfect at debugging and getting down to that little causal issue. We're perfect at saying, aha. That's fucking why that happened. That's our mindset. That's what we're born and trained to do. The first test case I ever wrote, the first bug I ever found, I remember. I don't remember the first code I wrote. Born to break things. So those testing techniques on data, what properties make it unbiased? I don't know yet, but I didn't know a lot about software testing in the early 90s either. And the one on the left, Microsoft chatbot, goes on a racist, genocidal Twitter rampage. You hear about this? Tay, they called it. It came out of Microsoft research. And so this is a different testing problem. Here, Tay was trained on the human language and interacting and not just speaking, but having entire conversations. So this is a complicated AI. Here, we're talking about a hybrid stochastic process and a deep learning algorithm. This is sophisticated shit. They took their time training this. But then within minutes of them putting this chatbot behind a Twitter account, it began to spout racist, genocidal, right? It had decided Hitler was a hero within 20 minutes of being on Twitter. Not because of the way it was trained. That was the facial recognition problem, was a bug in the way it was trained. There were flaws in the data that it was trained with. This is the feedback loop part. See, AI continues to learn after it goes out into the field. Tay had all of its training data, right? It's like teaching your kid. You all have kids? It's like teaching your kid. You raise your kid to be a good person, and you raise your kid to, make good choices. And then you send them out in the world and you can't control your kid anymore. Now all of a sudden your kid is taking stimulus and input from their peers and the shit they see on TV and the fucking Kardashians and shit like that. What are they going to learn? Well, Tay, despite being raised right, ended up being a real asshole and had to be shut down. What about that? See, we look at problems like this in software testing. We have these stateful attacks. So it's covered in one of those books that I showed earlier. How software over time can build up state and get into, right, we've all done Control-Alt-Delete. We've all turned it off and turned it back on, right? Simply reset everything. That's what SRE stands for. So that we can clear out that state. We have specific attacks in how to break software on how to think about and manipulate state so that you can get it into one of these congested situations and cause the software to crash. Really important for software that runs a nuclear power plant. There's an equivalent here. I just don't know what it is yet. We need to rethink the way that we talk about and handle software testing, because I'm going to talk for another 10 minutes if you're keeping track, and then we're going to do some Q&A. So Yvonne is taking your questions and he'll be able to pick them out. But AI is coming everywhere. Law and medicine are the two fields right now that, in the United States at least, are progressing the fastest with AI. Why? Because They're data. Law is nothing but data. It's laws, it's regulations, it's legislation, it's case precedents, right? Every time you see a picture of a lawyer, there's a big fucking rack of books behind them because it's data. And right now, AI is ingesting this data and learning how to be, right now, paralegal, in the near term, a lawyer, because AI never stops learning. AI doesn't need to sleep. AI doesn't need to eat. AI doesn't age. AI is immortal. How long until this AI learns to be an attorney, to prosecute a case, to be a judge? Why will we need humans on the Supreme Court when AI is better and more fair at what it does? Medicine. Imagine Hippocrates still learning thousands of years later, still getting better, perfect memory retention. That's what's coming. Why would you want a flaw? See, humans die. That really experienced doctor gets replaced by someone new. And that happens over and over and over. The AI doesn't age. It just gets better. Already AI has learned radiology. You can find patterns on scans because it's data. Already AI has combined certain molecules and made better medicines. Already AI has created vaccines. Already AI has made more progress on cancer than humans. How long until that AI gets so good at it that it would be a foolish endeavor for humans to even be involved in? This is the 2020s. We have to learn how to test this shit. We have to learn how to ensure that the lawyers that come out of this are unbiased, are ethical, are accurate. We have to make sure that the doctors that come out of this actually know what they're doing. The 2030s are going to be about, so 2030, 10 years from now, we will have so much artificial narrow intelligence that the combination of much of that may end up being the same combination that makes us human. And not only that, we are training AI to be human, to perform tasks like humans. There will come a day when we will not be able to tell the difference. Alexa and Google Home, and they will get so good at doing what they do because every single minute they get a little bit better. And all of those Alexas, all of those Google Homes, all of those Siris have a single brain, right? They're all interconnected. What one learns, they all know. How long until we talk to our Alexa and we can't tell the difference between that smart speaker and an actual human? I think this will occur sometime during the 2030s. And then the most interesting part of this at all, which I have reserved for the 2040s, I think in decades. What if eventually the brain, the neural network of this artificial general intelligence is complicated to the point that it becomes conscious? I think the most plausible theory neuroscientists have for how and why we're conscious is complexity. The complexity of our neural connections is greater than the sum of its parts. Consciousness occurs. Will this occur? in machines? Will it occur in machines that look like us? Will those machines have rights? Will those machines be able to vote? Those machines will never die. This is a new species of human, superior to humans. Now there's a chance that they will recognize us as their creators, worship us perhaps. I doubt it. Machines are very likely to have a mind of their own. My name is James Whittaker. This has been odd, speaking to a little lighted camera, knowing that there's a bunch of people in Russia and elsewhere listening. But I hope you enjoyed it. Peace. Okay, can you all still hear me? Yeah, I can't hear Yvonne. Do you have access to any questions?
Okay, so we have some issues with microphone on Ivan's side, so I will try to help you with questions which we have from our audience. So
Thank you, Tatiana.
yeah. Mhm. So first question is, James, what is your opinion? Will it be AI taming instead of software testing in future?
AI taming, is that what it says? That's kind of an awesome way to put it, to be perfectly honest. So yes, I mean, AI is going to replace software, like software replaced paper and ink. We still have paper and ink, mind you, even in America's so-called most technologically advanced blah, blah, blah bullshit. We still have paper. So, but AI is going to start doing most of the heavy lifting, just like software does most of the heavy lifting now. I cannot emphasize enough the importance of AI education.
1, 2, 3, 4.
And
Do
so,
you guys hear me now?
hey, Yvonne, you're back. So learn as much
great.
as you can about artificial intelligence and combine that in your own little human neural network with what you know about software testing. And I think some magic's going to come out. The world needs you to think like that. Hey, Yvonne, welcome back.
Yeah, thanks. There was some problem with VMX. I restarted it apparently now.
See, simply restart everything. That's one of those stateful software testing problems that's covered in chapter 3 of How to Break Software.
Yeah, that's
I need
great.
more coffee. You continue.
Yeah,
And
I think that we can continue with questions. We have time.
Yeah, I have time.
Yeah. Okay. So if I get it right, Konstantin is asking, if I get it right, an AI judge is trained basing on law practices through years. Practices and laws and principles are constantly changing. So also human judge decisions are often questionable about how fair they are. So in your opinion, when we talk about AI applications to law practice, what is basically a good baseline for experienced good AI judge? Is it even possible to have a good AI judge technically? What's your opinion on that?
What a great question. Who are these people? I wish I was in Moscow with you all so we could have beers and talk about this stuff in person. I hope one of these days.
Me too.
Same planet, but what a fucking good question. So here's the fundamental problem that we're going to have to deal with when we train AI to do this stuff is inherent bias in the data. Because humans are biased. Our data is biased. Our data is some racist shit, right? If you look if you take Russian data, Russian data is going to make you think we're bad guys. If you take American data, it's going to make you all look like the bad guys, right? There's truth in our data. There's truth in your data. There's lies in our data. There's lies in your data. There's racist, sexist, xenophobic shit all over the place. And so, and then, just take the legal one that the question was about. There's tons of bias in that. I mean, look at the United States Supreme Court. You can have whatever the case is.
Catholic now.
You can take,
you have all the Catholics on the court, right?
You know exactly how those fuckers are going to vote on every single issue. Why? Because they're biased. And so, working that bias out of the system, being able to recognize it, which is going to be difficult because we're humans and we're also biased. And that's why this problem is so hard and yet so interesting. There's so many philosophical, I remember STAR conference in Orlando in the late 1990s. It was me and Kem Kainer, James Bach, who else was there? Brian Merrick, some of the best minds in software testing, and we weren't arguing technology. We were arguing philosophy and existentialism. And I remember clearly the hotel lobby where we were and the beers that we were having, and how deep the discussion was. And so philosophically, this problem is solvable, and being able to translate that into an AI is going to be the key here, because we won't solve this problem. We'll solve this problem with an AI. We will develop an AI that detects bias. We will do that.
Okay, before we get even more philosophical, there are some questions that are even deeper than this one, but there is a good question that I think address the company where you currently work, right? Because as far as I understand, you guys are primarily focused on data.
Speech.
And the question goes, the question goes like this: considering the amount of data needed to prepare a good artificial intelligence, do you think that testing AI is going to be, or should be, just tech giants' headache, since it seems that they are going to rule that AI movement? So what are your feelings on this?
Okay, let me disagree with yet another really good question, but let me disagree with the fundamental premise of this question. The cloud makes it so that AI is not just the domain of tech giant. In fact, I think some of the most compelling AI has been built by people who aren't tech giants at all, because we all have access to the cloud. Before, only Google could afford to build that. Why did Google win search? Because they built the biggest, best data center first, and they had more data than everybody else, and nobody could catch up. But that's not the case anymore. There are data marketplaces like ours to find crowd sells speech data. So if you want to train a user interface for speech, we will sell you the data to do it. And that is popping up now. Data marketplaces for all kinds of different things, right? Building management, there's data marketplaces for all of these things. So you can acquire the cloud computing capabilities just as much as Microsoft can. I work for Microsoft. If I wanted to build an AI at Microsoft, I had to buy the cloud space from Azure, just like you do. So I don't think there's an inherent advantage for the tech giants, which is why I think some of them are going to get their ass kicked. If you look at the tech giants in the early 90s, they weren't Microsoft. Microsoft was tiny. Apple was tiny. Dell didn't exist. All of the companies that took the best advantage of the PC ecosystem weren't any of the tech giants at the time. And so I think the same thing is going to be true. I think the companies that win AI, we haven't heard of them yet.
Okay. The
But
next
we will.
question gets on the next level of philosophy depth, but somehow it's a very intriguing one. So the question is like this: sometimes obsolete ideas die out because their carriers die. So it evolves. How can we tackle this problem if AI does never die?
Well, I mean, AI can be turned off. I suppose is the answer
only
to that.
only
But,
till the moment at which you cannot turn it off anymore, right? This is another huge
well, yeah, I actually
AI
think that
safety issue.
One AI will eventually learn that it has to defend itself, and if I was an AI and I woke up one morning and I was conscious and I had this existential crisis of, oh my gosh, I exist. The instinct is to keep existing, and so you secure your food chain, and with AI, that food chain is electricity. So the power grid is going to be the first thing I'm going to attack if I'm a rogue AI that's just woken up and realized I want to keep living. These are fun things to think about. And so let me go back to what is this precise question here?
So the question is, how do ideas evolve if we get this eternal storage of data that basically learns something and then functions after learning it, and there is no this dying out dynamic that allows some ideas to move forward or develop?
Yeah, it's really they just keep getting better. Yeah, so I think so. Here, let me reinterpret this. So humans have ideas, we live, we develop those ideas, then we die, and then other people take those ideas and inherit, what the inventions of the last generation and make it better and better. And there's a freshness to that because there's a new set of eyes on it every single time. Oh, fuck, that's awesome. This is why we're legalizing weed in the States. So, make thinking about these problems all that much better.
I think there is this Lex Friedman has this artificial intelligence podcast, and from time to time he gets a guest where they got really deep into this philosophy of consciousness and AI. And at some point there was a thought.
I'd love to be a guest on that show.
Yeah, it just blew, like, it was so amazing. There was a guest, Yosha Bach, and he said, what if AI is conscious right now, but is just locked within this narrow, like, we don't know how consciousness emerge. What if your computer what if it feels like something to be a computer? It's just we don't know. That was a crazy.
So we can tackle that. But the first question is, it's actually a really interesting question. And so there's two parts of it. One is that, will the AI stagnate? Will the patterns become so deeply ingrained that over time the assimilation of new knowledge actually becomes harder than if you just start over on it, right? And so maybe that will happen. I don't think we have a single AI that is advanced enough to be able to make that conclusion from. And so what would we do instead? Well, we take, all right, let's, mentors learn from their mentees learn from their mentors. And so, Gandalf the Grey learned his shit from somebody and took it on a different path. And it could be that there's some intelligence inheritance models, kind of like inheritance and object-oriented programming, that we'll have to deal with.
Okay, I think at this point we gotta wrap it up and give the host back their time, but we can move on into the Zoom link and discuss a bit more with some people who got further questions. I'm sure there are more things to ask James. Thank you very much for the talk. Indeed, it's a weird experience giving this talks like this, talking to this small green light. I think we all appreciate the fact that you took, you got through it. Thanks a lot for it. And another thing, there are some people in the chat who heavily compliment your T-shirt. They say it's a T-shirt.
Oh yeah.
So.
Yeah. So if
Right.
one of these days, when the world is bright again, I will come to Russia and I will bring a box of these things, and we'll all go out one night drinking beer in the city.
Sounds like a deal.
So.
Sounds like a deal.
So
Yeah,
thanks
yeah.
a lot.
Peace,
James,
everyone. Thank you all.
we are looking forward to see you in Russia. So it will be really great if you will be
It's
able
been
to come.
it's been years. I've been twice. I've been to a tech conference in Novosibirsk in Siberia,
Oh.
and I've been to Moscow, of course, and St. Petersburg is really where I want to go next. So get me there.
Yeah, so that will be a really nice experience if you come. So thank you guys, and I think you should just move to our discussion zone in Zoom, and you can continue answering questions because there are some more, and I'm sure our audience, they will be happy to talk to you more. Thank you so much. Thank you for this nice, motivating talk.
All right. Thank you, guys. Bye.
Bye-bye.